All right, some statistics textbooks differentiate between two conditions of two samples. So if we're comparing two samples or two groups or two treatments or two conditions, um, some textbooks say when you have equal sample sizes, that means the sample size in group 1 is equal to the sample size in group 2, you should do this. When you have unequal sizes, you should do this. Well, I want to go through that situation when we have unequal sample sizes. In other words, the example that we went through with the Prozac versus Zoloft in the previous video, they had the same sample size. Both groups had 8 observations. But what if this is not true? What if this doesn't hold? Should we eliminate some scores so that we have equal sample sizes? Which score should we eliminate? The last one? Why the last one? What? We should never eliminate data if we have good data. So that's one rule. We want to take into account, though, the fact that we have unequal sample sizes. And unlike a lot of textbooks out there, the method I taught you for the independent sample T can apply to situations of both equal and unequal sample sizes. What we're doing is we're making an adjustment to the calculation of the standard error of the mean. But since we calculated pooled variance, we're okay. Let me try to explain. If n1 is larger than n2, then n1 minus 1 will be larger than n2 minus 1. In other words, if we look at the formula pooled variance, if we have a larger sample size here than here, we are giving this more weight because this number is going to be larger than that number. Okay? What that means is that this term here is going to be larger than that term. In other words, this is weighted more than this. So if we have 10 observations in sample 1 and 5 observations in sample 2, we're going to take this into, we're going to give this more weight because we're going to be multiplying this by 9, whereas we're going to be multiplying this by 4. 10 minus 1 is 9, 5 minus 1 is 4. So we're going to weight the variance estimate from the first sample more than we are the second sample. Now this makes complete sense, or it should make complete sense, and that is, if we make the homogeneity of variance assumption that the sampled populations have the same variance, then the best estimate of the population standard deviation will use information from both samples. We want all the information that we have. We want to use every little bit of data that we have. We want to use all that stuff. That stuff is telling us information is describing certain properties of the distribution, so we want to use it all. But when we have more observations in one sample than the other, then we have more information about the population from that sample than the other sample. And we should use that additional information, which is precisely what weighting accomplishes. What we do is we are using that information into our determination of the standard error, and we're using it, and we're using it in direct proportion to how much information we have. If we have twice the amount of information from one sample than the other, then we're going to weight those values twice as much as the others. Okay, so the lesson here to get is that if we have unequal sample sizes, you can do exactly what you do if we have equal sample sizes, because we are calculating pooled variance and we are weighting the variances according to the size of the samples. Hopefully that sets your mind at ease a little bit. We'll talk to you later.